Hi students, welcome back. This is Plus One Computer Science and Computer Application Chapter 4 Part 2 video. Before getting into the video, please do subscribe. So in the previous class, we started with key features of operating system and we have discussed about user interface and memory management. In this class, you'll be learning about file management, fault tolerance, process management and security management. Let us start with the third topic, that is process management. Process management is a function that includes creating and deleting process. So what is process? Process is nothing but a program, or you can say it as a job. The work done in CPU is actually called as process. It can be created, it can be deleted. So these two functions are done in process management, and we also should provide some mechanism for the process to communicate and synchronize with each other. So many process will be there in CPU, it will be scheduled, so we have to provide a mechanism to communicate with each other. So let us see what are the algorithms that are mainly used to allocate the job to the processor. First in, first out, shortest job first, round robin, and based on priority. So these four are the algorithms used to allocate the job to the processor. So let us start with the first algorithm, that is first in first out, FIFO scheduling. Now look at this picture. People are standing in line in front of ticket counter to receive the ticket. And this formation is actually called as queue. The person who gets into the queue first is the person who gets the ticket first and leave the ticket counter. And then the second person will get the ticket, and the person who enters new to the queue will be placed in the last position, and he or she will be the last person to get the ticket and leave the counter. This is first in, first out. That is what this scheduling, first in and first out. So this is the real-time example. Technically, the process that enters the queue first is executed first by the CPU, followed by the next, and so on. So the same method is used in the CPU for the process. So the process are executed in the order of queue. As they get in, they get the work done and leave the processor. So this is the first algorithm used in process management. Now let us move on to the second algorithm, that is shortest job first scheduling. Now look at this picture. Assume that we do have a shop here and few customers are waiting to place the order. And if the burgers are less in number, what will the shopkeeper do? They provide burger to the customer who orders less number of burgers. So this is the technique used in shortest job first. We do have four different customers with four different orders. Customer A with one order, customer B with six orders, and customer C with four, and so on. So here, based on the requirement, they distribute the burgers. So the minimum order will be considered first, and the large order should wait for a long time until they complete all the minimum orders. So here they satisfy lower to higher. That is why the name is shortest job first. So this is the real-time example. Technically, this algorithm works based on the size of the job being executed by the CPU. So for example, consider we do have two jobs A and B, and the size of job A is 6 kilobytes and size of job B is 9 kilobytes. Now analyze which one will execute first. Yes, job A will be executed first because less number of size is job A. So first job A will be assigned and then job B gets its turn. So this is the second algorithm in process management, that is shortest job first. Now let us move on to the third algorithm, round robin scheduling. So this algorithm is based on time sharing. So for example, let us consider round table conference. Here each students are asked to talk a few words about their school, and we do have fixed time. So let us start from student A. He or she is allowed to talk for 2 minutes. And after 2 minutes, the turn should be given to the next student. And so on. It moves so on. So moving on like this, at one point, student will not have any content to say. So at that time, they can leave the conference. So like this, the task will be done again and again until all the students complete their opinion. So in general, if the work is done, they can leave the place or else they have to wait for the next turn. This is round robin scheduling. So technically, round robin algorithm is designed for time sharing system. So in CPU, few jobs will be assigned and the time will be fixed in circular method. So here let us consider job A, B and C. So first job will be assigned, that is A will be assigned to CPU and then B and then C. So this turn will be taken again and again. It will be repeated again and again until each job completes its task. So this is the third algorithm in process management. Now let us move on to the fourth algorithm, that is based on priority. So for example, let us take teamwork. Here all the employees are given their own task, but few tasks will be considered as the most important one and priority will be given for that particular task. So based on the priority, job order will be arranged. That is, preference will be arranged based on the priority. So technically, the jobs are based on priority. Higher priority is more important than other jobs. So for example, let us consider two jobs A and B. Let's see their priority. Job A is having 5 and job B is having 7. Which is greater? Obviously, 7 is greater. So B will be assigned to CPU first and then A. So job B will be assigned to CPU first and then job A will be assigned as the second job. So this is the fourth algorithm of process management. And let us move on to the next feature of operating system, that is security management. So in general, security means protecting the data from hackers. So most of the time security is provided with username and password. So this security concept is provided to protect the software and data from hackers. And this operating system provides 3 levels of securities to the user end. So user end means final user. And the 3 levels are file access level, system level and network level. So let's see what is file access level. Permission can either be granted by the creator of the file or by the administrator of the system. You can create a file with password. That is what? File access level. So you can hide the data from third person. And then system level security. It is offered by the password in multi-user environment. For example, if you turn on the system, you may get multi-user account. You have to know the password to log into the user account. And finally, network level security. I hope you all know this. Whenever we use certain app using internet, we do have user account and password. So it is protected with security. For example, email system, that is Gmail, Yahoo Mail, Outlook and so on. All these are protected with user ID and password, and social network like Facebook, Twitter, everything is protected with username and password. So let's move on to the next feature of operating system, that is fault tolerance. The operating system should be robust, which means it should be strong enough. So for example, when you're working, if there is any fault with the application, the system should not crash. Instead, operating system should have that fault tolerance and it should say what went wrong and it should throw the error message. This is what fault tolerance. So when we use heavy application or games, most of the time there will be fault. At that time, system should not crash. Instead, it should close the application and it should throw some error message. So let us move on to the next feature of operating system, that is file management system. File management is data, data storage technique. It is a technique used to store the data. And the operating system manages files, folders, and directory system on a computer. And we do have general information of files stored in FAT, that is file allocation table. So example for file, it can be image format, it can be text format or Excel, PDF. All these are the different file formats. When you consider image, you can check the additional information about that image, like name of the image, where it is taken, what is the size of the image. All this informations you do get along with the picture. So that is what FAT, file allocation table. These additional informations are stored in FAT. And operating system helps to create, edit, copy, allocate memory to the files and also update the FAT. Updating the FAT means updating the information about file. Those information will be stored in FAT. And there are few other file management techniques available, like next generation file system. See, this next generation file system is actually used in Windows operating system, and ext2, this is used in Linux. This technique is used in Linux operating system. And let's move on to the next feature of operating system, that is multiprocessing. Multiprocessing has two or more processor for a single running process. Process means job. For one job, multiple processor will be available. Processing takes place in parallel is known as parallel processing. In parallel means at the same time multi-process will be done. That is what parallel. So they are called as parallel processing. So this parallel processing helps the system to work fast, that is high speed execution is possible. This will increase the power of computation. The job will be done very fast compared to single processing system. And the next feature of operating system is time sharing. Time sharing allows execution of multiple tasks or process concurrently. For each task, a fixed time is allocated. Based on the time each process should work. And this division of time is called as time sharing. Now look at the example. Here we do have 4 job, that is 4 tasks, and the CPU time, the time limit is 500 milliseconds. So milliseconds means it goes very faster. So that is the time given for each task to process. So the processor will switch rapidly between these 4 jobs. And if a process is completed, it will go out of this chain. So this is how time sharing is done, and all the process will be executed concurrently. And the last feature of operating system is distributed operating system, and it is used to access shared data and files that reside in any machine around the world using internet or intranet. It is just to access shared data and files. So what is meant by internet? Internet means if all the systems are connected globally, then it is called as internet. Then what is intranet? Intranet means all the systems connected within an organization is called as intranet, local. So that is what intranet. You can access the data or you can access the file as if it is in your own computer. And the advantage of distributed operating systems are a user can access any resource easily in the internet, and it improves the interaction with the customers and client, and finally it reduces the load on the host computer. So this is the overall advantages of distributed operating system. And this is the last topic of this lesson, that is prominent operating system, that is important operating system. Here we do have a student activity. One side operating system logos are given, and the other side the description of operating systems are given. What you have to do is draw the line between the operating system logo and the correct description. Like match the following, you have to identify the correct one. So try to do this, read the description and guess about which operating system this description is given. So all the best. That's all for today. Thank you.